We used to think, again, the brain was separate from the body and that the immune system and all that didn't affect the brain. Turns out that was all wrong, absolutely wrong.
Welcome everyone back to the School of Greatness podcast. I'm super excited about this. We have Dr. Rhonda Patrick in the house, who is a published scientist, health educator based in San Diego. She's also a Ph.D. in biomedical science, someone who has done extensive research on aging, cancer, nutrition, and so many other things about optimizing your health. So I'm so excited that you're here. Rhonda, thank you for taking the time.
Oh, I'm excited to be here too. I'm glad we finally made this happen.
Finally made it happen. I've been begging you to come on for years.
We just needed a pandemic to get you to go virtual.
To make it happen, you never leave anywhere from San Diego. You're just obsessed in the research all day, teaching the world about how to be healthier. And so we finally made it happen. We'll have to make it happen in person in the future as well. But I'm so excited about this because I feel like people need you and your information more than ever right now. Obviously, you've been sharing a ton of great content over on your podcast. And we are in a moment of a lot of high anxiety, a lot of high stress, and routine disruption. You know, my girlfriend who lives with me, she had plans, she had dreams, and those plans and dreams went on hold, just like most of the world. So what does that do to your body and immune system first when you have this routine disruption, anxiety at an all-time high, stress at an all-time high, uncertainty at an all-time high? How do we combat it? And what does that do to our immune system with all of that combined?
That's a huge question. That particular question hasn't been really empirically studied, but what I can tell you is there's a lot of, evidence, and in fact, a growing body of evidence that psychological stress itself, which is what I think you're referring to. I mean,
yes,
just the fear of the unknown, not knowing what, this COVID-19 illness is going to do, whether you're going to catch the virus, all those things, whether you're going to get your job, you're going to, keep your job or your housing. I mean, so many stresses associated with this pandemic. We do know that, psychological stress has a pretty profound effect on the immune system. And it's known to depress immune function on the one hand, but also to cause inflammation on the other hand. It's kind of like this weird, how is it doing both at the same time sort of deal. And it's funny, often in biology, you'll find a lot of systems like that, where on the one hand, something will increase inflammation, but on the other hand, it's suppressing the immune system. And you might think, well, inflammation is active immune system, right? So it's one of those, it's just, there's so many interconnected systems, and, one thing is doing, one gene can activate one thing and then activate another, and happens to be the opposite. So, but cortisol itself does increase with psychological stress, and we know that cortisol does depress the immune system.
Mm-hmm.
So
anytime we have stress, anxiety, overwhelm, a fight or flight mentality, emotionally, psychologically, it transforms into the body, weakening its immune system. Is that what I'm hearing you say?
Yes. You're more likely to probably succumb to a pathogen. And I think anybody, I remember I've gotten the flu twice. Like, maybe I've had it more. I just remember twice in my life, really. Once was during finals week in college, and it was like, I was taking like all the hard, I was taking graduate classes and everything at once. And it was like, I had this Spanish final, and my Spanish teacher was like, if you miss the final, you're going to get an F. And I had an A in the class. So I came into that final that day, and I had a fever, and I literally vomited like in the classroom. And
in the middle of the test.
On the day of the final, I vomited. Like, I was like so sick.
With your classmates around you, or
yes.
No way. You're just like, okay, I'm here. I don't want to fail, but I'm going to do whatever it takes.
I went right to the trash can and threw up.
No way.
So my teacher sent me home. That was like something I remember. That time I had the flu, and the other time I had it was right after I had my son. I was getting no sleep, and sleep is also really important for immune function. And so I got the flu then. But anyways, I think the point of my story was that I think people have their own anecdotes where they're like, they remember getting sick when they had this stressful thing happening, that sort of thing. So stress definitely can depress the immune system, for sure. And so that's definitely, and then, there's all sorts of other things that affect immune function as well. Diet, lifestyle, genetics.
Do you think there's a way to defend ourselves against all disease and viruses? Do you think it's possible if we have the purest mind and psychological well-being, we eat the perfect foods, we have 9 hours of sleep every night, we have the perfect environment, is it possible to just the immune system say, nope, anything that comes in through the body or the skin, like we're just going to reject it because we have defended ourselves so well?
I think the only way you're going to do that is if you never expose yourself to a pathogen somehow by living in a bubble. So no, I don't think that that you can fight off every single pathogen ever. It's not possible. And that mostly has to do with, when you're exposed to new pathogens, things that your body has never seen before, there's really two arms to your immune system. There's the innate immune response, which is what happens when you encounter any pathogen. It's sort of this generalized response where you're basically, trying to fight it off. And that happens through a variety of mechanisms involving mostly what are called myeloid cells, macrophages, neutrophils. These are cells that are like neutrophils, for example, produce hydrogen peroxide. They produce hyperchlorite, which is like bleach. They're producing these things inside of your body to fight off pathogens.
Your body produces bleach or bleach-like material?
Hyperchlorite, it does. Yeah, hydrogen peroxide as well. So
is this your immune system develops this, or is this like your cells? Is this what
your
is this?
neutrophils are producing it? It's a type.
What's
of
a neutrophil?
Cell. It's a type of immune cell.
Okay.
Your various types of immune cells. You have myeloid cells and you have lymphoid cells. Most people are familiar with lymphoid cells, which are B and T cells. You've probably heard of those, right? And those also could be involved somewhat in the adaptive immune response, in the innate, but mostly they're involved in what's called the adaptive immune response. And that's the immune response most people are aware of that don't, study biology. That's the response where your B cells basically form what are called like B memory cells, and they produce antibodies, which can then recognize specific regions of a virus and protect you from that virus, protect you from the virus entering your cells. If you don't have, but if you've never been exposed to that virus, then you're not going to have that antibody, right? You're not going to have that adaptive immune system hasn't been activated. And so you don't have protection against it. So you rely on the innate one only.
Oh, so we actually want to be exposed to viruses and other bad, I guess, bugs. We want to be exposed to some degree, but not full on attack, so that our body can build up antibodies. Is that what I'm hearing you say?
I think that's an accurate statement. I think, it was thought for a long time that, all pathogens were bad, all microbes were bad. And we wanted to have, this clean hygiene. We wanted to all the time.
Never touch anything with your hands. Make sure you cover everything all the time. Yeah.
And now, and this is how science is. The more tools you have, the more you can investigate questions and learn more answers from doing experiments. So as time goes on, you're sort of, your ideas change and knowledge changes, right? And that's science. Science is the changing of it. So, we know that microbes now, we've got the microbiome, we've got the skin microbiome, the gut microbiome. The bacteria that are on our skin, the bacteria that are in our gut, also have important roles in helping us, and helping our immune system, in fact. Actually, there's been many studies showing now that early life exposure to dirt, or even like pet dander, growing up with like a dog, can help protect against asthma and even other types of autoimmune diseases. And it's really important in the first year of life. So like when my son was born, I was like taking him out in the dirt, I was trying to get him all, dirty instead of like years ago, like, my grandparents' generation, it was like, oh, you never want to go in the dirt, you know, because it's dirty and you can get sick. And, you know, so, you know, obviously we've learned a lot more since then. But even gut microbiome, the gut, like the composition of what's in your gut plays a major role in actually regulating your immune cells. And particularly, so what happens is, you know, bacteria in our gut will ferment certain types of fermentable carbohydrates that we eat. So these are carbohydrates that we don't digest. And they tend to be in plants and fruits. And there's many examples of it, like you can find pectin or inulin or beta glucans. You know, there's lots of different types that are found in a variety of plants. And these bacteria will ferment these types of fiber, and they will produce a variety of different compounds, almost like little drug factories in our gut. And these compounds, some of them are called short chain fatty acids because they're little tiny fatty acids. They get released into the bloodstream, and they basically send signals. It's like this signaling molecule that tells our T cells to make more of this type. And one of the types of T cells it makes is a type called regulatory T cells. And regulatory T cells play a very important role in preventing your immune system from attacking its own tissue, thinking its own tissue is foreign. So obviously it plays a very important role in autoimmune disease.
So how do we get more of these T cells that are good?
Well, you know, I think one thing to keep in mind would be what regulates the gut microbiome. One of the major things that regulates the gut microbiome is what I just said, eating a diverse array of fermentable fiber. Because
give me an example. What's a diverse array?
So you have blueberries, you have, you know, you have nuts, mushrooms, you have some, you know, dark leafy greens. These have different types of, or, you know, you've got onions and garlic. Those have a different type of fermentable fiber. That should be differentiated from non-fermentable fiber, which would be cellulose, ligands. Well, just like, broccoli has fermentable fibers, but yeah, most of the bulk of fiber in plants is non-fermentable. So what that's doing is basically just helping move stuff through the intestines, right? Pushing it out.
The fiber.
That's important.
The fiber is pulling it down and cleaning it out.
Right. And that's also important. But the fermentable fiber, the stuff that can be eaten by this bacteria in our gut, like that is the good stuff. That's what's allowing the bacteria to make short chain fatty acids.
What are the top 3 to 5 tea foods? I'm trying to simplify for myself. These foods that can really develop that. Yeah. What do you
different? So the thing is, different foods have different types, and different types feed different types of bacteria. So if you want, you know, like for example, some people want to hear, oh, well, I can supplement with inulin. I can get an inulin powder. Inulin is a type of fermentable fiber. You can find it. You can find it in a variety of plants. I think onions, for example. But you know, if you only eat inulin, then you're going to be basically feeding a certain types of bacteria that use inulin or that ferment.
So the variety is what you're looking for.
That helps with the diversity, you know, because these bacteria are playing different roles. So
interesting.
You know,
I have been under the assumption that eating the same thing every day is good. It's like eating it clean, like a little bit of chicken, lots of veggies, and eating it pretty much every meal is the right way to go in terms of like my health, nutrients, in terms of like body composition, how I want to look and feel. Is that something that I should be going away from and diversifying what I eat every day? Or
well, it sounds like you said vegetables. That's a lot in vegetable. There's a lot of types of vegetables, right? So it's kind of nice. Look, I'm just as guilty. Like for convenience, I'm busy. Like I know my husband gets tired of it, but I'm like the same. It's so much easier to have the same thing
every day.
Meals because I find the thing that's healthiest and easiest to make. And you know, there's days where, let's say, you know, I'm not working all day, then I can be more creative and I have more time. But generally speaking, it's easier to kind of stick to the same thing. But it's nice.
If you were going to, let's say you came up with a new company, a product that was a meal that you had to have the same meal every day for lunch and dinner and snack. And this would be the thing that you could sell to people. What would be included in that meal that you were like, you know what? if you don't have all the variety and time to make these foods all day, but if you could do this 3 times a day, you're setting yourself up for a really good immune system and good gut bacteria.
The same meal 3 times a day, or different
Yes,
meals?
same
Yeah.
meal.
So I would say basically omega. I would get salmon. I would get wild Alaskan salmon, and that's because salmon is one of the best sources of the marine omega-3 fatty acids, EPA and DHA, which are extremely important for health, and particularly brain health, but even cardiovascular health. I mean, there's just been so much emerging evidence showing that the omega-3 fatty acids are really important for brain health and for cardiovascular health.
Piece
So
of
that
wild
would be
caught salmon.
That would be my protein. And it's also lowest in mercury. There's like 4 micrograms of mercury, or sorry, 2 micrograms of mercury per 4 ounces cooked. So that's really low in mercury. I would definitely
cooked or raw fish.
Well, actually cooking it even lowers the mercury bioavailability even more. So definitely, and raw, you don't want to I think there's too much concern with parasites and all that. So I would say
cooking meat. Okay.
Number two, I would say I have to, and in fact, I always feel like I'm depriving myself, and I'm kind of quoting my mentor here a little bit, if I don't have dark leafy greens with a meal. Literally, like every meal, I like to have dark leafy greens. And
what are the top 2 or 3?
I would say kale, because I would also like to have my sulforaphane. And sulforaphane, it plays an important role in so many, there's just so much evidence that sulforaphane, I think, may be important for longevity. So that would be my greens.
Kale.
And I like maybe sauteed. Sauteed would be good. Because it's just, you can't really eat raw kale unless you put it in a smoothie. Unless you put it in a smoothie.
Exactly.
Which I actually do. I drink my smoothie. I have blueberries. So maybe I would add the avocado. I'd have an avocado and some blueberries, a little cup of blueberries.
And that's it for your meal.
Yeah, that would be my
So you'd have wild Alaskan salmon, dark leafy greens, sauteed kale. You'd have blueberries and some avocado.
And an avocado.
If you ate those 4 things every day, multiple times a day, if that's what you could only eat, you feel like it would set you up for good amount of success.
I do.
Interesting.
Yes. Well, there's a lot of, so in kale, kale is probably one of the best sources of lutein and zeaxanthin, which are what are called carotenoids. And carotenoids you're probably familiar with, and people listening or watching this are probably familiar with beta carotene. That's like the probably most famous. That's like the poster child for carotenoids. Beta carotene is a carotenoid. It has antioxidant activity itself, but it also can be converted into vitamin A. Lutein and zeaxanthin are really interesting because they accumulate in 2 regions, in the rods and cones in the eye, and they've been shown to play an important role in preventing age-related macular degeneration. But they've also really been shown to play an important role in the brain. And there's this accumulating evidence that this stuff is accumulating in the brain. And it really hasn't been known why. And the reason I say that is because lutein and zeaxanthin, because of their molecular structure, they're really good at basically sequestering singlet oxygen. And that plays a role in like damaging the eye. So like when you're out in the sun, exposed to the sun, and cataracts and things like that. So that plays a role, and you're basically eye aging, quote unquote, right? But in the brain, there's no light. So why is this stuff accumulating in the brain? And there's just been quite a few studies over the past 5 years or so, maybe last 7 years, correlating it with cognitive function and improved cognitive function and delayed brain aging. So and there's like studies, correlating plasma levels of lutein and zeaxanthin with, improved cognitive function. There's been randomized controlled trials supplementing with lutein and zeaxanthin, improving cognitive function in elderly adults. It's always nice to have a randomized controlled trial because that really helps establish causation. When you have, these studies looking at associations, at the end of the day, it's an association, and you never know, it could be some other factor, right, playing a role.
Sure.
But so the lutein and zeaxanthin in kale, you've got some fiber, a little bit of fermentable fiber. You've got the sulforaphane, which has been shown to increase. It's been shown in human studies to increase glutathione, in plasma and also in the brain, which is amazing. Glutathione is one of the major antioxidant systems in the body, and particularly in the brain. And I know we were kind of chatting before we got started about your former life as what I didn't realize even existed was this, which arena football you called it. And it sounds like that TBI could be a big thing in arena football.
A lot of hits in the head, that's for sure.
Right. Well, glutathione is one of the major antioxidants in the brain and plays a very important role, particularly with any injury in the brain. So sulforaphane increases glutathione. It increases the enzymes that make glutathione and use it, and subsequently increases glutathione levels.
I saw maybe it was another doctor, I'm trying to figure out who said this, that there was some research actually potentially saying that kale was not good for you, that it had some negative side effects as well. I don't know if you've seen that research or if that's just something.
There's no research I've seen on that. I've heard it. But it's one of those things where people like to talk about potential anti-nutrients, and one of what they're calling an anti-nutrient is actually sulforaphane, because it can compete with iodine for transport into the thyroid. And but there's been studies, so for human studies where they've loaded up with sulforaphane, and there's been no effect on thyroid function. Those were short-term, like a week-long studies. There have been long-term studies on animals that actually have hypothyroidism. They were given sulforaphane, and believe it or not, actually they were given broccoli sprouts extract, which is one of the best.
I hear those are amazing for you.
Yes. So broccoli sprouts have like 100 times more sulforaphane than mature broccoli. Well, anyways,
so should we throw some broccoli sprouts on top of the kale or the avocado?
The broccoli sprouts actually would, if I could add more, I would absolutely put the broccoli sprouts in there. Yes.
Okay.
But my point was that the animals that had hypothyroidism, it didn't make their hypothyroidism any worse at all. In fact, it helped the antioxidant status of their thyroid and improved some functions.
Wow.
So I think that doesn't mean, people with hypothyroidism shouldn't be, weary or concerned about consuming too much sulforaphane, particularly if they're not getting iodine. Most people aren't iodine deficient. It's like in salt, most people are eating foods that already have salt in them. Now, iodine deficiency is not a big thing, particularly in the United States. But so I would say that those statements by some people that are kind of more into the camp of don't eat any plants,
right,
aren't really
not enough research on it. Yeah,
there's not. There may be, you might find one study with one case report with a female who had some crazy disease or something, and she was juicing like just ungodly amounts of kale every day, where it's like, I mean, okay, like maybe you can create a situation
sure
where
there's not enough research backing it though. Yeah, but
yeah, so
I'm curious about this. You have some great points here. I love your 5 foods that we should be eating for every meal. Now, I'm a 37-year-old man, but I've got I like to think curiosity and imagination of a 7-year-old, but I also have the palate of a 7-year-old, and I don't like blueberries. I don't like avocado. I'm the pickiest eater. I'm probably a pickier eater than your child. And I want to ask you, for the picky eaters of the world who don't eat berries and don't like avocado or aren't creative enough to go that far, and they're limited in their creative thinking in terms of foods, is it better to just have the supplementation, the vitamins and supplements that are the exact same nutrients, and just take the supplements and vitamins as opposed to the actual food itself? Or is the organic, fresh caught food always better than the fish oil or the blueberry vitamin? What do you think about that?
Yeah, so I think that there's huge differences when you're talking about eating a food versus taking a supplement. And I do think, for example, a multivitamin supplement is I take it every day, and I think it's great insurance to make sure, because there are 40 essential micronutrients, which are vitamins, minerals, and essential fatty acids and amino acids we have to get from our diet. And they're important for not only helping us, not die, for example,
right,
scurvy, but also for long-term function, for the way we age. preventing insidious damage. But there's also a variety of these compounds we don't know about. There's the fermentable fibers that are feeding the gut microbiome, and which are making all these chemicals like little drug factories in our gut that are regulating the immune system. We've got polyphenols, like blueberries have been shown, in multiple clinical studies, it's been shown to increase blood flow to the brain and improve cognitive function and memory in both young adolescents and older adults. And this was thought to be due to the anthocyanins in blueberries. And, so there's, food has so many components, probably so many things we haven't even discovered yet. So many compounds that were just, there's this new compound that was discovered in dark leafy greens called sulfaquinolone or something, which is now been shown to have a specific purpose of feeding the gut microbiome, kind of like the fermentable fiber. So it's one of those things where food has so much to it, and there's so many parts to the story. It's not just about getting the vitamin, right? It's not just about getting that one mineral. And I will say that when I was a postdoc with Dr. Bruce Ames at the Children's Hospital, Oakland Research Institute, there was a variety of clinical studies that I was a part of where my colleagues had designed this nutrient dense bar that had a variety of vitamins and minerals. It also had DHA, which is one of the marine omega-3 fatty acids found in fish. And it also had fiber, a fiber matrix. And there was a variety of studies that we were doing in obese and lean individuals. And
so it was like the ultimate food bar. It was like everything you need in this meal.
It was like it was like the micronutrient bar, where you were giving the micronutrients, but you were delivering them with a food matrix, like fiber, right?
Yes.
And so there's all these benefits that were found from this bar that were particularly benefits found in people that were overweight or obese, that we didn't ask them to change their diet. They were eating their same diet, but you give them this bar on top of that and you would have improvements. And inflammation, in HDL cholesterol, which is a good type of cholesterol. So you'd have all these improvements. But if you took away the food matrix, and just had the bar without the fiber and just the micronutrients, some of those benefits would go away. But if you gave the fiber by itself, the benefits would go away. It was the whole package. It was everything together that was important. So, with that said, I do think there is a place for supplementation, and, particularly with fish oil. I think fish oil is one of those supplements that every day I take it, and I think that there's just mounting evidence that it's beneficial. I mean, high dose, it has to be in the right dose for some people. And it's been shown to really lower triglycerides, for example. But again, there's conflicting studies. And a lot of times when you look at these clinical trials, it all has to do with dose. It has to do with, were they taking a statin, for example, which can sort of mask some of the benefits. There's all sorts of things that are complications. It complicates everything. And then you get all this data and you're like, wait a minute, but yesterday it was not good for you. Today it is good for you,
right? How are you supposed to know when there's so much information out there about medical news, about health news, nutrition news, supplement news? How do you know what to trust when there's just so much news out there about what's working and what's not working?
I mean, it's hard to know. It's hard. It's hard for me to kind of sort through it. Then you add this layer of genetics. That's also complicating, particularly with the randomized controlled trials. Like there's genes that people have where they actually need a higher dose of fish oil to have benefits, which is super interesting. There's also genes where people that get omega-3 from the plant source, because there's a plant form, alpha linoleic acid, ALA, that for chia seeds or flax seeds or walnuts, they don't convert that ALA into the EPA and DHA very well. And those EPA and DHA are ultimately what are regulating everything that's important for health. So again, you have the genetics that comes into, and this is also the case for studies on saturated fat, the genetics plays a role in that as well. So there's so many factors when designing a clinical trial. And I think the burden is on the researchers. The researchers have to come to a consensus,
right,
and realize.
But then a decade later, they may come to a new consensus with new research, where it's like we thought, I don't know, leafy greens were healthy, but now it's actually killing you, right? It's like not that it's going to happen, but I'm just saying it seems like over decades, what scientists and researchers think sometimes is accurate, we find later evidence that it may not be 100% true.
That is true. That is true. But I think when you have overwhelming evidence in multiple fields and multiple areas, so you have the epidemiological evidence, you have the associative studies, you have the randomized controlled trials where you start and you give someone something and then you measure an endpoint.
The
and
double placebo testing, everything.
Right. And then you have the mechanistic studies where you start to look at how it's happening and you do these animal studies, that together combined, the whole, comprehensive literature, I would say is what really strengthens.
Yeah. The matrix of studies
when
makes it a whole.
Right. When everything starts to come and point to that direction.
I have so many questions. This one just came to my mind really quick as I live in Los Angeles. I'm from Ohio. So being from Ohio, you grow up eating meat and cheese and milk. I remember I lived in a dorm. In 8th grade, I went to a private school, boarding school, and I lived in a dorm with a bunch of other kids in middle school. And I actually had a milk dispenser, a 5-gallon whole milk dispenser. And I would drink that every 3 days by myself. 5 gallons within 3 days because I thought milk was good. You're supposed to drink it all day long. So, you drink it before sleep, everything. I have a question about being in LA now. Growing up in Ohio, which is all about meat and potatoes, now being in LA, it's all about being vegan. And everything is around either keto or veganism or paleo or vegan. It's like you're good, you're bad, you're right, you're wrong. There's documentaries that are coming out all the time about veganism, all that stuff. If you had to calculate with your wealth of information and knowledge, who would be healthier? The person who is vegan eating the best foods all day, or the meat eater eating the best, healthiest foods all day? Who do you think would have a healthier?
The meat eater also would be including eating vegetables,
including plants and vegetables as well. But
so they're an omnivore.
Yes, they're eating meat, but they're also eating all the other good foods. Or someone who's eating all the other good foods, excluding meat.
So
veganism win,
taking out all the processed foods in both camps, right?
Both camps, no unhealthy, whole foods, healthy. One is having meat every day, a portion of meat, and one is not having meat. Who is a healthier, happier human being that lives longer?
Well, I can tell you, I don't know, but we can talk about what the evidence has shown. And I think probably the strongest evidence to date, most of this evidence is unfortunately epidemiological, because you're never going to get a randomized controlled trial that's 50 years long. I mean, that's not going to happen. It's too expensive and people won't follow the same diet for that long, right? So you won't ever have a longevity study. That's a randomized controlled trial. Okay. But looking at the epidemiological studies, for a long time, you'd have study after study coming out showing, vegetarians have a lower what's called all-cause mortality than non-vegetarians, or than people that eat animal meat. All-cause mortality means basically dying from all types of diseases that are non-accidental.
Diabetes,
right? Cancer, type 2 diabetes,
obesity.
Yeah, exactly. Heart disease. So
vegetarians die less.
Lots of studies have shown that, but with the problem with epidemiological studies is there's what are called confounding factors. So you have people that are also obese, you have people that are sedentary, you have people that exercise, you have people that smoke, you have, so what about all those other things? How do those come into play, right?
Interesting.
And so there have now been studies, large studies that have looked at confounding factors and have found, yes, vegetarians do have lower all-cause mortality, particularly cancer-related mortality, than people who eat meat. But when you take all the unhealthy lifestyle factors away, so people that are not obese, don't smoke, that are physically active, and that don't consume excessive alcohol, if they eat meat, they have the same mortality rate as a vegetarian. But if you take the meat eater and you add one of those in, like obesity, then they're going to have a higher, higher mortality rate than the vegetarian. So basically,
why is that?
Meat has a different amino acid profile, and part of that amino acid profile can activate a hormone, a very important hormone, but it's like a double-edged sword hormone. It's called IGF-1, insulin growth factor like 1. And this hormone is an important hormone. Like during development, it helps you grow. I mean, it's needed to grow. People that have genetic, polymorphisms in genes that affect that pathway and have less of it have stunted growth. So it's important for growth. It's important for muscle repair. Like you want IGF-1 in your muscles to help repair muscles after you injure them or after you exercise, right? That's the type of injury
But can't you get that from supplementation, from protein or supplements as well?
Well, so this is the bottom line, is that the IGF-1, which is activated by essential amino acids, you've got like leucine, for example, methionine. It also is important in the brain for growing new neurons. I'm just telling you the importance of it, because the problem with IGF-1 is that as we age and we accumulate damage within our cells, and this happens to everyone, and you have a cell that, let's say a cell gets enough damage, it has a mutation that could potentially become a cancer-causing mutation. The IGF-1 that's around, which is around a lot more in meat eaters, it allows a damaged cell to overcome signals in our body that will usually kill it and say, oh, this has got damage. If we don't kill it, it could become cancer. IGF-1 goes, no, grow, keep growing. And so IGF-1,
it's a growth hormone. It's a growth hormone or stimulus.
Exactly what it is. Yeah. And in fact,
so it's going to grow any cancer or any disease.
It's going to allow things to grow more. Yeah. So that's kind of part of the problem.
Is that why
someone is obese or a smoker, or, doing things that are, excess, causing excess damage, then that could put you at risk, right?
Because I've heard stories and seen cases of people that were eating meat, got some type of cancer, whether it be early form cancer or some stage of cancer, went complete vegetarian, vegan, and it stopped growing. I've heard stories of that. I don't know if that's 100% accurate or if there's other factors that played into that. Without chemo, without those types of things, is that possible?
Well, I've certainly heard anecdotal stories of that as well, and there's been animal studies showing that. And when you take an animal and let's say you inject it with a human cancer cell to form a tumor, and then you give that animal a high protein versus low protein diet, then the low protein diet blunts the cancer growth, whereas the high one. But that doesn't mean that eating meat causes cancer.
Gotcha.
It doesn't mean that. It means that if you already have cancer,
it can accelerate it potentially.
It can potentially, yeah. I think that the key here also is exercise. Exercise, helps take that IGF-1 and move it into the brain and move it into muscle cells where it's doing good stuff. You want IGF-1 in your brain. IGF-1 is important to grow new neurons, which, as we age, neurodegenerative disease is a big risk, and you want to grow new neurons in old age. It also allows existing neurons to survive. So exercise increases IGF-1 in the brain. It also helps increase it in muscle tissue as well. So I think that's one of the reasons why you look at the meat eaters and the ones that are physically active, not obese. Basically, if you don't have these unhealthy lifestyle factors, then I think that eating meat is healthy. And honestly, I think that a vegetarian, you really you have to do a lot of work to make sure that you're getting all the right nutrients. There's risk factors for deficiencies in zinc, which is found in meat products. Risk factors for deficiencies in obviously B12 and other things. Just making sure you're getting the right profile. So you definitely want to make sure you're. And I don't know what all the combinations are. Like you have to eat the quinoa, the beans, and the
right. The proteins. What would be if you were a meat eater, but you said, you know what, I want to cut out certain types of meat. I want to be a more conscious meat eater, if that's a thing. And I want to be a healthier meat eater. And I only want to choose like 1 to 3 different types of meat. We've got wild Alaskan caught salmon as one piece of meat. What would be the other 2 that you would add if these were the only meats you're going to eat, because you were to try to minimize your consumption of meat? What would be the other 2 types of meat that you think would be beneficial for your health and brain memory? And
I would say based on interesting studies that have been done looking at what is called epigenetic age. Epigenetic age is probably one of the I would say it's the fastest growing biomarkers for what's called biological age. and versus chronological age. So people can be biologically younger or biologically older than their chronological age.
Right. I'm 37, but I could be 17. Right. Like
yeah,
with my
maybe.
health, my internal health.
I would say genetics would probably play a bigger role in that than lifestyle. I don't think diet and lifestyle will put you back that far, but yes.
Or I could look like I'm 45 or 55 if I was smoking all day, drinking all day, eating everything crap.
Obese, not sedentary. There's lots of lifestyle factors that can make you have an older biological age, and those are the things we just mentioned: obesity, sedentary, smoking, excess alcohol consumption. But there's also been studies looking at dietary patterns and their supplement intake as well. And what epigenetic age is basically it looks at what are called methylation patterns. It's like basically a carbon with 3 hydrogen atoms, and what they're doing is they're basically sitting on top of your DNA and changing the way genes are turned on and turned off. And what's really interesting is that this methylation pattern, this work was really pioneered by Dr. Steve Horvath at UCLA, and he basically showed that he could look at he could take some DNA and look at the methylation pattern, and with like 96% accuracy, he could predict your age plus or minus 4 years. Like, it's super accurate. And then he's developed a bunch of other clocks, these epigenetic aging clocks, that can more accurately predict biological age. And so what he's found is that there's an association with lower biological epigenetic age when you're eating fish or poultry, which I found very interesting. I know this was a very long-winded answer to your question.
So birds and fish.
So based on that, I kind of, for a while, was like, well, what's the real benefit of poultry? I might, why not get more red meat and have more iron? And, so that study kind of made me think about it. And I'm like, oh, well, that's because red meat wasn't associated with the lower epigenetic age.
Wow.
So I thought that was really interesting.
So would you say eating red meat is making us older?
No, I don't think there's evidence of that. Okay. I will say that the red meat studies are extremely nuanced, because lots of times stuff is lumped together with processed meat, like, the lunch meats and the bacon and then the sausage and the processed meat. There's a layer of complication on that, and that is that it has nitrites in it. Nitrites are preservatives. The problem is that they can also form nitrosamines in the body, which are potential carcinogens. They can cause DNA damage and do all sorts of terrible things. So a lot of red meat studies are really, there's a lot of nuance there with that. And in fact, with a lot of the red meat studies, there's been a lot of studies looking at red meat consumption and type 2 diabetes risk. And it's weird, because there's an increased risk with red meat consumption. Study after study after. So once in a while, I'll get like a vegan that'll throw me a question and they'll send me some links, and I'm like, wow, there's something to this. Like, I didn't realize that, so I'll look into it. And this is, how you kind of learn things from really, good questions and from people that send you links to studies.
Sure.
And so my team and I were looking into this, and we finally, after reading just, dozens of studies, there was one consistent theme within all the studies showing that red meat consumption increases type 2 diabetes risk. And that was BMI. It only did it in people with a high BMI for the most part.
Body mass index, is that BMI?
Yes. Yeah. And BMI is not a great, like someone that has a lot of muscle, can be categorized as high BMI. So it's not a great indicator. But generally speaking, if you're obese, you've got a higher BMI.
So poultry and fish would be the things that are the best meats to eat, based on what I'm hearing you say from your mentor and from the research so far, what we have.
I would say, yeah. I mean, so far,
if you're only picking two meats, it's fish and poultry, right?
I hate to say it. I don't really know, but
right.
I found those studies interesting.
Okay.
And I would say that I still am not convinced that red meat is bad.
Gotcha.
Unless you're obese or you're overweight and you're eating red meat, and you got to work on work on the losing weight.
How old is your child right now?
2.5.
2.5.
Yes.
As a mom and a scientist and researcher, what are the healthy foods out there that people in the mass population think as healthy that you will never want your child to eat?
Oh, I think there's all sorts of processed toddler foods you'll find out there. And I've experimented with a couple on myself. I wear a continuous glucose monitor just to see how my body responds to various foods in terms of increasing blood glucose levels. So it's called postprandial blood glucose. And I'm also interested in my fasting blood glucose levels, how different lifestyle factors affect that. And I should mention this, that basically we were talking all about these studies with eating meat and vegetarians. And, you know, there's also a huge layer of complication with genetics. Believe it or not,
Yeah.
there are genes that people have that eating a high protein diet makes them actually gain weight and have poor lipids. And there are genes that people have that eating a high protein diet makes them lose weight. The complete opposite.
So you need to know your you need to know your genetics first, really, before the diet you eat.
The genetics may tell you the why of some of the conflicting research. And this goes for fats as well. There are genes, people that eat saturated fat, they can have an increased glucose response versus most of the time, what increases your postprandial glucose response is actually carbohydrates, particularly refined carbohydrates. But there are situations that's not true. There was this beautiful study published back in 2015 in the Journal of Cell Metabolism. It was done at the Weizmann Institute in Israel. And I love this study because they put continuous glucose monitors like I'm wearing now on 800 people. They gave these people a variety of different types of foods. You know, they gave them high fat, they gave them high refined carbohydrate like white bread, they gave them complex carbohydrate like a banana, measured their glucose response to a variety of foods. And what was so enlightening and illuminating about this study was that everyone had different responses to these foods. And they also then did genetic testing on these people, and they measured microbiome and also physical activity. And it turns out all those things play a role in their blood glucose response: their genetics, their microbiome composition, how much they exercise. So, you know, I think, and then sleep also, but that wasn't part of the study. That's another, those are other studies. But the point is that, you know, we're sitting here talking about people's response to, for example, red meat. And I think that as moving forward, you know, this field of this interaction between genes and diet, it's called nutrigenomics. I think that field is growing and more clinical studies will start to include it. The problem is it's more expensive. Anytime you have to add another clinical test, particularly if it involves, you know, getting a sample of DNA, although these days now you can get them from saliva, and so it shouldn't be as difficult. But there's these foods that are organic, almond butter, little snacks and all this. And so I was trying this stuff, and just tiny little thing raised my blood glucose levels like just unbelievably high, like as if I had eaten like 2 meals.
No way.
You know, and so yeah, it was insane. Some of these stuff that just has some a little bit of added sugar or a little, you know, so it's just really, I would stay away from all those foods that are packaged, like, you know, I see like children eating these squeezy foods and stuff, and I've never given my son that. I know that it's a lot of work making food.
Of course,
it's definitely a lot of work. But there's like companies out there now that'll like send you like already like made, you know, great organic real food.
Exactly.
So there's ways to help.
What are like 5 foods that you think are hurting us on a daily basis, like in terms of just like sugar, bread, rice? Like, what would you say are the 5s that we should never be eating? Unless
I would say, I mean, I don't know if I can categorize it to 5s. I would say that probably the biggest thing to avoid is refined carbohydrates. Refined carbohydrates are really, you know,
like where do we see refined carbohydrates the most? Is that cereals? Is that bread?
Yes, cereals, breads. Most of the time, I mean, not all breads have them, but like, you know, a lot of the white breads and stuff, white flour, like in pizza, you know, you know, cookies, cakes, all that, pretzels, like those things. The refined carbohydrates, there's really just no nutritional value. I mean, the whole point of food is, you know, to provide your body with the nutrients it needs to, you know, to not only be healthy now, but to also age healthy. And I think that people get really focused a lot on macronutrients like protein, carbohydrate, fat, and they don't realize that all these micronutrients that I mentioned, there's 40 that you have to get from your diet. You know, like those are important. These things they're what are called cofactors for enzymes that are running your metabolism, enzymes that are producing neurotransmitters in your brain so your brain can function. And, you know, if you don't get enough, like magnesium, you know, magnesium is found at the center of a chlorophyll molecule. Chlorophyll is what give plants their green color.
Yeah.
So magnesium is very high in dark leafy greens. Almost half the country in the United States doesn't get enough magnesium from their food. There's been, you know, large nutritional surveys and stuff that have shown that year after year. And the problem with magnesium is, like, you know, you need it to make energy. You need it to make and use energy. But you also need it to repair damage, DNA damage. And so you can imagine what happens if you're short in that essential mineral. Your body might actually triage the mineral to the short-term thing, energy, making energy. If you can't make energy, you're going to die. So of course your body's going to say, any magnesium I have, it's going to go to that essential process. DNA repair, like that's something that only matters in your 5th, 6th, 7th decade of life. Cancer crops up, right? So who cares if that's not, you know, 100% optimally working? This whole idea of sort of triaging micronutrients is called the triage theory. It was put forth by my mentor, Dr. Bruce Ames, and he published a couple of papers with supporting evidence of that theory. But the theory is basically, and again, there's some supporting evidence with a couple of micronutrients that basically these essential, you know, vitamins and minerals, if you're short in them, they're triaged to systems based on binding constants. For example, some minerals will bind tighter to some enzymes versus other ones. And so the ones that are binding tighter are the enzymes that are important for short-term health, to prevent you from dying, basically, versus long-term health. Things like repairing damaged DNA, which doesn't matter right now. You can't see DNA damage. You know, it's not something, but it's happening. It's happening all the time. So I think micronutrients are really important, and the food that you're going to find foods that you're going to find them in are whole foods. You're going to find them in plants. You're going to find them in meats. Meats are a great source of micronutrients. Really? Organ meats are also a great source.
Organ meats.
A lot of people, organ meats like liver. That would be probably the stuff that I know. It's just it's really an acquired taste. I recently found there's a company that I found will make ground meat with a certain percentage of liver and kidney, and
so it tastes better.
Another one. And if I put it like in a, you know, if I make like a chili or something, like
you can't taste it. You're just like,
you can't taste it. And so I'm getting, you know, some of the organ meats, which is kind of fun as well.
Oh my gosh. I remember when I went to my first time I went to Mexico City, it was early 2008. I was wearing a full arm cast. So I'm already 6'4" gringo white guy in the middle of Mexico. I'm a foot taller than everyone in Mexico City. I'm wearing this cast because I had surgery on my wrist. I broke my wrist. They did a bone graft from my hip to my wrist playing arena football. That's how I got injured. And I went to Mexico City. I stayed in a $7 a day hostel right near the center of Mexico City. And I said to myself, you know what? I have the palate of a 7-year-old, but I'm going to be adventurous on this trip. I'm going to try things. I'm going to expand my horizons. And I'm just going to say yes to foods. And there was one point I went to a lucha libre match, a luchador match, which is like the wrestling of Mexico, right? Where they wear masks and they wrestle. And outside of this wrestling match, I went to watch as a fan. I went outside, and there was all these street carts of food outside of this match. And I said, you know what? Give me everything, to this one guy. And he started saying, I was like, what is this? And he was saying all these things. And I heard him say corazon, which is heart. And I was like, oh, that's the heart. And then one was a tongue, and one was the liver, and this and this. And I said, throw it all in there. And so he made me a taco with all of it. And it's probably because it was street meat. It wasn't that healthy. I was sick for the next 3 days. But I'm always weary of that stuff. So make sure you get organic, clean meats when you do it.
Okay, so you're kind of reminding me. I went to Japan a couple of years ago, and same deal. Like my husband and I went to this sushi place, and the chef, there was no English, and there was just stuff on the menu, and we just got it, and apparently it was like tongue and all sorts of.
Oh no!
And this is, I think it was
raw.
Think it was no, it was slightly cooked.
Oh
yeah, it was slightly cooked, but there was another sushi place we went to, and if you don't speak Japanese, you get the one for all sushi menu
Oh,
because
yeah,
it's
yeah,
like,
yeah.
and so we went there, and so we, of course didn't speak Japanese, and so we got whatever they gave us, and it like had turtle or something, and I was just so sad because I love
Oh,
turtles and I didn't want
no.
to eat the turtle. Anyways, so
Oh, man. Okay, so the foods, the foods we're here, we should not be eating: cereal, breads, pizzas, cookies, cakes, anything with refined carbs, refined sugars. No, no.
that's
Just
probably the
say
biggest
no.
thing to cut out. I think cutting that out, if people could cut that out, the sweetened, sugar sweetened beverages,
All that
huge. I
stuff.
mean, this,
What are the things that are super healthy marketed wise? I mean, beyond cereals, breads, and pizza, which they say they try to make them sound healthy, but the things that might seem healthier that we shouldn't be eating, are there certain fruits and vegetables or other things that maybe like, you know what, these actually hurt the body than help them?
well, I think I haven't seen any research showing that fruits and vegetables hurt the body, but there are fruits, I've been wearing my continuous glucose monitor. There are fruits that I can tell you for sure raise my postprandial blood glucose levels insanely high and still leave me hungry and unsatiated. And that would be grapes. The
Really?
grapes are like there. So there was this one time I was traveling and my son was like, I don't know, he was less than one. And I was trying to get him a fruit cup it had some cantaloupe, because he was eating solid foods at that point, but grapes are a choking hazard. And so like the grapes, I'm like, oh no, let me get it. I was like eating the grapes out of the little fruit cup real quick because I didn't want him to have the even potential of grabbing them. And my blood glucose levels just rose so high. I mean, it was insane. So then I tested it again. And same thing, tested it again, same thing. So I would say
Does that have to do with DNA, your DNA, or would it be different for someone else's DNA or
I
genes?
think it just has to do with the sugar, the ratio of sugar to fiber. So one of the things that's really consistent with lowering the postprandial glucose response is fiber, more fiber. And that was actually shown in that study that I mentioned, the Weissman Institute study with 800 people. One thing that was consistent throughout that was that high fiber did slow the glucose response. But
So if you
grapes have
had
a
a
lot of
little
sugar.
bit, if you had like some almond butter by itself, the glucose levels would shoot up. But if you had almond butter with, I don't know, some fiber, it
Well,
might go down.
actually, what's really interesting is that you bring up another important point, interesting point. Almond butter typically doesn't have a lot of sugar unless it's added sugar. I mean, so
Some
I get
honey or
almond butter.
yeah, or
Yeah,
whatever.
and you can have a little bit in there, and it actually won't really raise your blood glucose levels, particularly because protein also seems to blunt
Mm.
some of that. But what's interesting is there's been some studies, and I've tested this myself. If I eat like protein or fiber, and you eat it like 10 minutes before you are going to eat, let's say, some grapes, or in someone else's case, like you, who's maybe eating a
A
cookie or
cake,
something, right? Yeah.
a whole
So,
cake. No.
it actually lowers the blood glucose levels. It lowers the postprandial blood glucose levels of protein. This has been shown in a couple of studies in people with type 2 diabetes.
So if I eat a cake for dinner by itself, my glucose levels are going to go up. If I have meat, fiber, and then 10 minutes later have a little bit of gelato or a little bit of tiramisu or something, a
It's
little
better than the tiramisu. Yeah, it's better than it
it's,
by itself. That probably is why, I mean, humans probably notice that's why dessert comes after the meal, right?
man,
You
I
know?
just eat dessert for breakfast, lunch, and dinner growing up, Um, okay, this is fascinating. So no grapes.
Yeah. So if you're talking about the so-called healthy foods, I think that there's some people also can have a big, a bowl of oatmeal with a bunch of, stuff in it, and they may have a higher blood glucose response. That also really, I think, does depend a lot on people's exercise routines. Like I've
Mm-hmm.
noticed in myself that if I go out for a run, a bowl of oatmeal doesn't really affect me as much as if I don't, So
We're talking about health in general here, but we're talking about the brain and food connection. Right now in the world, it seems like mental health and depression is a hot topic. It's something a lot of people are talking about. They're having mental health challenges, depression challenges. And I'm sure there's many factors to this: social media, comparison, bad foods, a lack of exercise, a lack of sleep, anxiety, up all night, environment, lack of purpose, there's a lot of social factors probably that tie into mental health challenges. How important is food by itself in relating to minimizing depression, social anxiety, and mental health?
I think food is extremely important because it's directly linked to obesity, and obesity itself causes low-grade inflammation. And foods that are really high, particularly when you combine a high saturated fat with a high refined sugar. So let's say you're drinking your glass of milk with your cookie. Like that's the worst because you're getting the saturated fat and the sugar.
That's my whole childhood.
And that's been shown to cause a very high, what's called postprandial inflammatory response. So we've been talking about postprandial glucose response, which is after you eat, so postprandial. There's a inflammatory response that also occurs after eating. And inflammation itself has been shown to, inflammatory molecules cross the blood-brain barrier, and they play a role in basically depressing dopamine signaling and serotonin and all sorts of affecting neurotransmitters and brain function. And there's been studies directly showing that if you inject a person with an inflammatory cytokine, it causes depressive symptoms versus
really
injected with saline. Yes.
So the more inflammation we have in the body, it increases depression.
Exactly. Inflammation. We used to think, again, the brain was separate from the body, and that the immune system and all that didn't affect the brain. Turns out that was all wrong. Absolutely wrong. And these inflammatory mediators do get into the brain, and they get into the brain and they change, they're changing the firing of certain neurotransmitters and things like that. They're also activating the resident immune cells in the brain called microglia, astrocytes, microglia, a type of astrocyte. And, that also is linked to depression. And we put out a little short video on this, on an animated video actually, on inflammation and depression, and talk about a lot of the studies because it's something I don't think people realize, that the food you eat, and not only the food you eat, your lifestyle, being obese and overweight, being sedentary, exercise is one of the best anti-inflammatory medicines you can get, period. And it also happens to be one of the best lifestyle remedies for depression as well. And I mean, randomized controlled trials showing that, all sorts of evidence. So
is this any type of exercise, or are you a HIIT training, a cardio, a 30 minutes, 60 minutes? What's your opinion?
Well, there's been studies looking at, I would say the large body of evidence seems to show aerobic exercise is really important with respect to depression. And that is because aerobic exercise leads to increases in what's called brain-derived neurotrophic factor, BDNF as it's called. It's basically a growth factor that's produced. You can, after just 20 minutes of a moderate intensity workout, you can increase your level. You can find levels increase by like up to 30% in plasma. It crosses into the brain, and in the brain, it does a lot of things. Not only does it do what IGF-1 does, it actually grows new neurons. It helps you grow new neurons, and it helps your neurons survive. So it plays an important role in preventing brain aging. But something else very unique that it does, it plays a role in what's called neuroplasticity. Yeah. Neuroplasticity is like your brain's ability to adapt to stressful conditions. I mean, this is what children can do pretty good. As you get older, neuroplasticity goes down, as does everything. But neuroplasticity is important for being able to cope with stress, like the stress of a pandemic, for example. More neuroplasticity helps with those stressful divorce people are going through, or losing your job. Lots of stressful things, but neuroplasticity helps the brain cope with that. And brain-derived neurotrophic factor helps increase neuroplasticity, which decreases with age. So again, aerobic exercise was important, but there's been studies linking strength training to lower depression rates as well.
Yeah, any type of exercise will help.
Exactly, I do, but I really think that aerobic, there's a place for aerobic with respect to the BDNF, the brain-derived neurotrophic factor.
I always tell people that every day I try to put myself through some type of physical pain that makes me feel discomfort, whether that's sweating for 10 minutes or a 2-hour workout or playing basketball, hiking, whatever. I try to put my mind and body through something where I'm like, gosh, I don't want to do this. But by putting myself through pain, controlled pain, it sets me up to be more under control when there is chaos and pain. And I
Right.
think that's the key we should get to, is like controlled pain, healthy pain, so that you're not out of control when there is chaos and pain in the world.
What you're describing, scientists often refer to as hormesis, and that is basically a little bit of stress on the body, like exercise.
Mm-hmm.
Basically, because our body tries to maintain what's called homeostasis, a little bit of stress will cause our body to respond to that stress with a lot of anti-stress,
Right.
anti-inflammatory, antioxidant, growing new brain cells, all these beneficial things. So
Wow.
a little bit of stress gives you a lot of good stuff, right?
Interesting.
Whereas low grade chronic stress all the time, it doesn't do anything. You're not getting that. You're not getting that powerful.
Okay. Yeah,
response.
this is power. This is amazing. I'm going to say something that I hope I don't offend anyone when I say it. That I am all about self-love, self-care, loving yourself for who you are, accepting yourself for where you're at in your life, physically, emotionally, environment, financially, all that. The more I hear you talk about this, the quote unquote self-love movement of accept who you are and accept where you're at with your body and what you eat, and it's okay to eat whatever you want, just love yourself for who you are, is that self-love mentality, that specific type of mentality, killing people and hurting them if they aren't willing to adapt no, it's not okay to continue to eat whatever you want all the time and just love yourself and accept yourself for who you are. You have to make sure you arm your body and your mind and your health with the nutrients, the tools, the exercise in order to decrease depression and increase happiness.
I think that there's absolutely, if you're going to just eat what you want and accept being obese, that you'll be causing yourself more harm, and both physically and mentally. And that also probably affects your loved ones as well, you know, that care about you, or perhaps that you're interacting with and you're in a terrible mood. And so, when your neighbor's happy, you're happy, right? So I think that there's part of this movement. I think there's a fine balance between, you don't want to have your expectations so high that you can never be happy.
Yeah,
right?
and I'm never going to look
Like,
perfect, and someone's always skinnier than me, and
I'm never going to have blue eyes. I'm never, so if I'm always like, well, only people with blue eyes are the prettiest, like, then I'll never be happy. So like, that's an unreasonable expectation, right? In my mind. So, I mean, there are things where, like, I'm never going to be a billionaire. And if that's all I wanted in life, to be happy, I'll never be happy. So there are things I think that you can, there's a certain balance between, I mean, you want your expectations to be high in a way. You want to always aim for what aim for the stars in a way, and try to like work hard to get there. So what I'm trying to say is, I think that self-love movement came from somewhere, right? I think there was something to that, right? But I think it sort of spiraled out of control, and what's happened now is you're saying, well, accept things that I don't want to change, rather than you can, because you can change that. You can lose weight. You can eat different foods and get
make
healthier.
different decisions.
People that are eating refined sugar, people that are drinking these sugar sweetened beverages, and there's a lot of people, maybe not so many people listening to the podcast or watching it, but there are people that do. And there's been studies that have shown refined sugar acts on the reward pathway in the brain, dopamine pathway, in a very similar manner to controlled substances, drugs like nicotine,
yes,
methamphetamine,
yep.
Not to the same degree, but they're acting on the same systems, and they're
it increases a feel-good hormone when you take it for the moment, but then it makes you decline afterwards and crash, right?
It does. And I think the important point to realize with that is that when you take that away, when you stop, what happens is there is a withdrawal. And it's been shown, at least with, for example, with nicotine studies, that your dopamine's getting constantly fired. And so what's called dopamine receptors, which basically the dopamine acts on to make you feel good. Those start to decrease because your neurons are going, oh, well, I have so much of this around, I don't need so many of the receptors. So when you take away that thing that's causing the dopamine all the time to go away, you have fewer receptors, and now you don't feel as much. I mean, it's just really bad. You're not feeling any amount of dopamine, right? But it's been shown that that sort of normalizes within 3 months. And 3 months is a long time, but it's actually not that long.
Of cutting out the sugar, you mean?
This has been shown with nicotine. I'm just drawing a parallel.
Gotcha. Yeah,
I'm drawing a parallel saying, look, it's not going to be easy the first month.
It's
not going to be easy.
It's so hard.
It's not going to be easy the first month. It may not be easy the second month, but it's going to get easier. And it's not only is it going to get easier, you're going to be happier.
Your body's going to regulate itself. The hormones are going to regulate, right? Things are going to self-regulate.
Things start to get back to normal. Exactly.
It's very challenging, but it's necessary to get healthier and happier, right?
It is. I don't think people realize that, depression, it's not just a genetic disorder. It's not just something that can't be fixed ever. In some cases, there are definitely genetic cases of depression. I'm not saying that that's not the case.
But can you heal depression through food and nutrition and exercise?
Well, there have been studies that have shown that exercise can be a treatment for depression. And there have been studies that shown changing someone's diet can also improve depressive scores. And particularly the combined two is even more robust, which makes sense. So there's something for people to realize, people that are maybe eating a not so healthy diet, people that are overweight, definitely obese. And if they do have depression, that there very well could be a link between the diet, the lifestyle, the obesity. Fat cells itself, they also they produce inflammatory cytokines. So independent of the whole eating the diet and the postprandial inflammatory response, just having fat, like particularly visceral fat, like around your organs and stuff, like this stuff is causing low-grade inflammation. And do you know what low-grade inflammation is? It means that you're basically activating your immune cells a little bit all the time. And activated immune cells require a ton of energy. So you're taking energy away from your brain.
From defending itself, yeah.
From just having, having a great day energy.
So just having energy.
It's like a sink. Exactly. Just having energy. It's a sink. Low-grade inflammation. I mean, you were telling me this, we were chatting a little bit earlier about how you were eating this terrible diet back when you were doing your arena football, and you were always tired.
Always tired.
Low-grade inflammation, it's an energy sink because it requires so much energy to activate your immune cells. And there's only so much energy. It's like a triage, right? It's triaging there.
It's taken somewhere else. And it takes you away from your mission, from your vision of your life, from your career, from your energy with your family, your friends.
Yeah, you have to have energy. I mean, it takes motivation to want to go to the gym. It takes motivation also to want to like do stuff or to talk to people, Is there a genetic thing or DNA thing that holds someone back from losing that weight if they've tried for years? Or is this still, they're just lacking the discipline? What is that? There's absolutely many genes that regulate obesity. And I'll just tell you, my mother-in-law, she is also she's not obese. She's, has in the past had an overweight problem and has tried. I mean, she's the kind of person that tries and goes all in, and she has tried every diet, just everything, and just nothing seemed to work. So, I mean,
how does someone like that, if they've tried, and it's just like, you know what, I'm beating myself up, the diets I'm trying, the exercise is not working, what do they need to shift?
Well, so you asked about genetics, and there is a really important role for genetics as well. But I think that in order to know that, you're going to have to measure biomarkers in your blood. So you're going to have to measure lipids like your LDL cholesterol, different particle sizes of those cholesterol, inflammatory biomarkers like high sensitivity reactive protein, your triglycerides, your HbA1c, which is a long-term measure of your long-term blood glucose levels. Measure those things. And also you can get a genetic test. There's a variety of genetic testing services out there, 23andMe, Ancestry DNA. I do have a genetic report that basically we look exclusively or looking at genes that are affecting, basically interacting with diet. So people that are eating a high protein diet, some people with a certain SNP, which is a one change in one nucleotide of DNA in a gene, basically can gain more weight. And the opposite is true, like I mentioned, or eating the ratio of saturated fat to polyunsaturated and monounsaturated fat. So saturated fats found in foods like dairy, red meat, fatty cuts of red meat, polyunsaturated fats found in fish, monounsaturated fat is found in olive oil, olives, nuts. So these things, like even the ratio of those things can affect, depending on someone's genetics, their ability to gain or lose weight.
But can you
and more so, like even people, there's some people have it where they eat a high carbohydrate diet and they gain more weight.
So so it's not as simple as what I'm hearing you say as just eat less calories a day and you should lose weight.
Not always.
If you suppress the calorie intake, you're going to burn more, and eventually you're going to burn,
I think that's the one thing that's pretty tried and true, is that your caloric restriction, most of the time people will, lose weight.
Lose weight. Gotcha.
They will.
Okay.
But, the question is, how sustainable is that? So you maybe what you would need to do, the other thing is that a lot of times obesity, there's a dysregulation in hormones. Hormones like insulin, leptin is another big one.
Yeah.
And you have to reset those hormones in order to have a normal biology.
Yes.
And sometimes resetting those hormones takes a reset that's kind of a strong stressor, like a long fast. A long fast, where you're basically resetting those things, and that's what did it for my mother-in-law. So that was my long story.
She did a long fast and helped her reset.
A couple of them. So she did. Now, by the way, when I say a long fast, typically intermittent fasting is anything less than 48 hours. A longer fast would be longer than 48 hours.
3 plus days.
Yeah. No, she did, the first time she did a 3-day. She started out by doing sort of a caloric restriction, low calorie diet, just to kind of get her into it. And then she did a 3-day fast where she didn't eat anything, a little bit of salt. She would take a little bit of salt in and drink some water. And then she did 4 days. And she did this separated by a month. And that reset her metabolism. And all of a sudden she started losing weight.
Wow.
And this has also been the case for a few other friends of mine, particularly one that was morbidly obese, and he lost 180 pounds.
Oh my gosh. I want to be respectful of your time, because I could ask you 78 more questions right now, but I would love to do a whole nother episode if you're down in the future on fasting, the power of fastings, what to do with fasting, anti-aging, longevity. I'd love to do another episode if you're down in the future. So maybe if people, and I know you've got tons of resources on this that people can go listen to on your podcast, on your YouTube channel and everywhere. But maybe if enough people bombard you and say, come back on Lewis's show, we can do another episode in 6 months or something. Because I want to be respectful of your time. But fasting is something I want to talk about, because I do intermittent fasting, and I've listened to some of your own episodes on your show about it, which is super powerful. So people need to go listen to that. The one question I want to finish with before I ask you the final 2 questions I ask everyone is the main vitamins and supplements you feel like every human being should be taking every single day. What are the supplements that you take and you recommend for us? If we could take 3 to 5 every day, whether we're eating great food or bad food, what would you recommend?
So I will say, of course, that I'm not giving medical advice. I'm not a medical doctor. I will tell you that there are a few supplements that I think are important, and I think the evidence shows are important, and that I take every day. The first is vitamin D. And, vitamin D actually it gets converted into a steroid hormone. So it's a hormone, not just a vitamin, it's a hormone. And it regulates 5% of the protein encoding human genome. That's a lot. 5% genes, 5% of all your genes
is vitamin D.
Need vitamin D
to
do its thing. Right. It's a lot. Right?
Is there, can you overdose on vitamin D?
Well, here's the thing with vitamin D. And the reason I think it's so important, because you can make it from the sun, and you have exposure to UVB radiation. You make vitamin D3 in your skin, but you need the UVB radiation to do that. And UVB radiation, certain times of the year in certain parts of the world, northern latitudes, doesn't reach the atmosphere, 5 to 6 months out of the year. long time, you know, maybe 5 months, I don't know, fall, winter, you know. And so people in northern latitudes, the way they're adapted to that is they typically have fair skin, because melanin, which is pigment that helps you gives your skin pigment, and pigment protects you from the burning rays of the sun. It protects you from getting skin cancer, from, you know, basically people that are living closer to the equators in southern regions. So you have like, you know, South Asia, South India, Africa,
Brazil.
they have more, Brazil, exactly. They have more melanin, right? They have darker skin. Which is great when you're close to the equator and you're in the sun all the time, right? Because you can make vitamin D. But when you take a person with that darker skin pigmentation and you move them, as now we're a global country, right? People live from all over the world, live in the United States, and they live in a place in like Minnesota or Washington State or New York. You know, they're going to be severely vitamin D deficient.
Wow.
You know, they're not getting that UVB radiation.
All those exchange students from Brazil going to Wisconsin, make sure you got your vitamin D supplements.
But here's the thing. 70% of the entire United States population, everyone included, has what's called insufficient vitamin D levels. So not just people with dark skin, everyone. And that's because we stay indoors now. We've got our computers, we've got, you know, offices, we're not out farming like we used to, and we wear sunscreen when we are out. Sunscreen blocks UVB radiation to protect us from the burning rays of the sun. So the bottom line is most people aren't getting enough vitamin D. And you asked, can you take too much vitamin D? Well, vitamin D is fat soluble. It is stored in fat. There have been upper limits. So the National Nutrition Board of the Institute of Medicine set the tolerable upper intake at 4,000 IUs a day. But there's been studies showing that 10,000 IUs a day still has no toxicity effects. And that's even long-term for several years. Some people do require a higher vitamin D dose, particularly people that are more deficient. The only way you're going to know is to get a blood test. Getting a blood test is really important.
Yeah.
Blood levels between 40 to 60 nanograms per milliliter are ideal, according to all-cause mortality studies and things like that. But
okay.
I think that, and also people have SNPs, by the way. SNPs, meaning genes that regulate vitamin D production. So I've had now 5 friends of mine that have SNPs they've found out from using our genetic report, because they were supplementing with 7,000 IUs of vitamin D a day, and they were still deficient and couldn't figure out why.
My goodness. And
so people, I know it's one of those things, and you wouldn't, and see, it's important to get a blood test. You would never know. You're taking, let's say you're taking your 5,000 IUs a day supplement, and you never get a blood test, you're going to think you're fine. So blood test is really important. It's really important. You can order them at home. You know, people don't want to go to the doctor's office, you can order them at home.
Right. So I mean, should we be? I mean, with the times that there are right now, staying inside is killing us. Then, even though we're supposed to stay inside and stay safe.
So you're opening a whole can of worms, because I think that you know, look, there's no evidence yet that vitamin D helps prevent or treat COVID-19. Zero evidence of that. But what I will say is that there is mounting evidence that severe cases of COVID-19, people that are in ICUs, on ventilators, people that have severe cases, 98% of the severe cases, people are vitamin D deficient.
Oh my gosh.
In multiple studies in Philippines, Indonesia, New Orleans, whereas you get like 4% of people with severe cases are vitamin D sufficient. Multiple studies have been showing this, and there's a really important mechanistic link here. First of all, we know from genetic studies, people that are genetically low in vitamin D, because of like some of those SNPs I mentioned, if you look at those SNPs itself, and look at people that have those SNPs, we know they're genetically prone to low levels of vitamin D. And the only thing you look at is their genetics. They have a higher death rate from respiratory tract infections than people without those SNPs. I love these studies because it's called Mendelian randomization. The reason I love it is because there's all sorts of studies showing that low vitamin D levels also increases the risk of X, Y, and Z. But low vitamin D levels means you're out in the sun less. Maybe you're less physically active. So there's all these confounding factors. But when you just take the gene and you group that person based on their gene only, not on their vitamin D levels, and it's a way of randomizing them in a way, because there's no way that there's all these confounding factors with the genetics, right?
Yeah.
So there's also randomized controlled trials. There's 25 different randomized controlled trials that were all analyzed together, showing that Vitamin D supplementation decreases respiratory tract infections by 50% in people that are deficient, and by 10% in people that already have sufficient levels but still take a supplement. All right, that's not COVID-19. Again, there's
That's
no
just,
evidence.
yeah.
This is not, that this needs to be tested.
This is just good health practice to have vitamin D no
It
matter.
is. I personally think that there is a strong possibility, and this is a hypothesis, that vitamin D levels may play a role in the severity of COVID-19. It's not going to stop you from getting COVID-19. I think it may play a role in the severity of it, and meaning how your body responds to it.
How long it takes you to heal, recover,
and just how severe of a case you have. Is it like a mild case of a cold or a mild flu, or is it something that's going to take you into the ICU?
Wow.
I think that's a hypothesis that needs to be tested, but based on some of the evidence I talked about, and based on the fact that what's really known is that vitamin D is important for immune function in so many respects, because there's vitamin D receptors on many different immune cells, and it plays an important role in many different immune functions. But in addition to that, the way the SARS-CoV-2 virus, which is the virus that causes COVID-19 illness, the way it gets into a cell is through a receptor called the ACE2 receptor. The ACE2 receptor also regulates a lot of things. It regulates blood pressure, fluid retention, kidney function. It turns out that when the virus binds to that receptor and gets into the cell, it's what called down regulates that receptor. We talked about that before with dopamine. Down regulates, it means it takes that receptor and pulls it inside. And so there's fewer of those receptors on the cell surface to do its job. And this was shown with SARS-CoV-1, which caused the original SARS outbreak back in 2003. And that was shown to increase disease severity. Having less of ACE2, believe it or not, the way that this thing gets into the cells, the ACE2, is the very thing that's needed to prevent serious lung injury. There's tons of animal studies showing that lung injury itself requires ACE2, but ACE2 gets decreased because lung injury decreases. And it's one of the ways that causes acute respiratory distress syndrome, ARDS, acute lung injury. So having ACE2 protects you. And what does vitamin D do? Well, rodent studies have shown, if you give an animal vitamin D and cause acute lung injury, the ACE2 levels go up, and it protects them from the acute lung injury. ACE2 levels don't go up to animals that were given vitamin D but didn't have a lung injury. So in other words, the lung injury itself causes ACE2 to go down, but the vitamin D made it go back up. So what vitamin D is doing is maintaining homeostasis. Vitamin D is not a drug. It's not going to just increase ACE2 full stop in someone that doesn't have lower levels, at least according to rodent studies. So the bottom line here is, I think that emerging evidence suggests there is possibly a role for vitamin D in modulating disease severity. I know there are randomized controlled trials that are underway to test this. It's currently still a hypothesis, but I do think it is most people are getting insufficient vitamin D, and particularly now it's probably even worse. Elderly people are more at risk. People with darker skin, people with obesity is also, because fat soluble vitamin D is less bioavailable. So anyways, my point is that I think vitamin D is important to take, and certainly people can talk to their health practitioners about it in general, and particularly now. Fish oil is another one. I'll not ramble on as long. Fish oil is another one. And a multivitamin, I think. I think those are like the basic important ones. And fish oil, I think there's a variety of brands out there. You want to get a high quality one. Fish oil is very prone to oxidation. You want to get a higher quality one and keep it in the refrigerator. And there's sites out there like Labdoor that have third-party tested different oxidative markers in fish oil brands. So you can look at those sites to find a good brand.
Sure. Okay. This is fascinating, and I love listening to your show. Found My Fitness. People can listen to it on iTunes, Apple, Spotify, all the places. Also foundmyfitness.com. You have a premium section for more, where you do a Q&A, coaching type of answering questions for people, right?
I do, yeah. So Found My Fitness, all one word. Yeah, iTunes, also on YouTube. And I do have a premium where I don't do ads or sponsors, but I do have we are a premium subscription where people can they get sort of perks by supporting us. And one of those perks is a monthly Q&A I do. So they submit questions. It's live, but if you don't want it live, you also get access to it on YouTube and also a private podcast feed as well.
I love it. Yeah, you've got some incredible stuff on your podcast. I love listening to it and diving in on your research. So everyone should go listen there. If you want to convince Rhonda to come back on at some point in the future, whether it's this year or next year, to talk about, since I have the biological age of a 7-year-old with a curiosity mind, if you want to hear from my perspective on fasting, anti-aging, longevity, then make sure to tag her on Instagram and Twitter and all those places when you're listening to this. So she maybe will come back on in the future. Where else can we follow you? Where do you hang out the most on social media?
Twitter, Instagram, Found My Fitness, all one word. And I'm also on Facebook and YouTube. YouTube is my YouTube channel, Found My Fitness.
Amazing.
That's it.
Amazing.
That's all the places.
This is the final couple questions that I ask everyone at the end of my interviews. This is called the 3 truths. So I'd like you to imagine a hypothetical question that you're as old as you want to be. You've figured out the longevity code. You're 300 years old. You're 120, however old you want to be. But eventually, you got to turn the lights off and go to the next place after you leave this earth. You got to go at some point. And you've gotten to achieve every dream that you have. Rhonda, you have changed the world. You've cured cancer. Whatever it is the dreams are, you've done it. You've grown up. You've seen your family grow up and have an amazing life. And for whatever reason, all of your work, materials, your research, your findings, your podcast videos, they all have to go with you to the next place. So no one has access to any more of your content. Any of your research, it's all gone for whatever reason. Hypothetical question. And you could share 3 things you know to be true with the world before you go. And these would be the only 3 things that people to have to remember you by, and 3 lessons you would share with the world. 3 important things they should do. What would you say are your 3 truths?
Oh, wow. I would say I would definitely, there is a low-hanging fruit to be happy, and that low-hanging fruit is accomplished through making sure your body has the right micronutrients and exercise. I think that there's a low-hanging fruit. The low-hanging fruit is the main thing. I would probably the common theme. The low-hanging fruit to living longer also is basically through just trying to find and get the right micronutrients from your food. And when you do that, you end up eating healthier, because there's no micronutrients in refined foods. So that's going to help your body. I think help your body be healthier as well. And then I think lastly, I would say to just enjoy the things that you love doing. I mean, being happy it's so important, to take time and enjoy those things for sure.
I love it. Back to the basics. I love it. Before I ask the final question, I want to acknowledge you, Rhonda, for just being an incredible source of helpful wisdom and knowledge in a time and in a place where there's so much noise. You bring peace, clarity, found research, and you do it with such grace and wisdom and joy and happiness. So I'm just acknowledging you for constantly showing up every day, being a mom, being a wife, taking care of yourself, being a human guinea pig, so that we can all learn how to become happier, healthier as well. And I just really appreciate all the work you do for all of us. It's really helpful. So I thank you for that. My final question for you is, what is your definition of greatness?
My definition of greatness. Oh, I think my definition of greatness is honesty. I think that is the most important. Honesty, just pure honesty, period.
I love it.
Yeah.
Dr. Rhonda Patrick, thank you so much for taking the time. I appreciate it. Very grateful.
Thank you. Thank you for all the flattering words too, Lewis. It was really fun chatting with you.
Thank you so much for watching this interview with Dr. Rhonda Patrick. If you enjoyed it, make sure to like this, click the subscribe button, and leave a comment. And also, if you want more great health tips, check out this video right here.
It has led to increase in homicides and violence and suicides around the world. And we've gotten higher on these refined omega-6s and low on omega-3s.